Did you know that the moon is not completely dry? That's right, it has water, and that's just the beginning of the lunar secrets we're going to unveil today. Our silvery celestial companion, the moon, is more than just a pretty face in our night sky. It's a treasure trove of mysteries waiting to be uncovered. From the phenomenon of tidal locking, which keeps one side of the moon forever hidden from our view, to the existence of an exosphere, an incredibly thin atmosphere composed of elements like helium, neon, and hydrogen. The moon's surface also boasts an array of intriguing features such as lunar swirls and transient lunar phenomena, whose origins continue to baffle scientists. Underneath its seemingly barren exterior, the moon hides water ice in shadowy craters and a layer of fragmented material known as regolith. And let's not forget the lunar highlands and morea, the two distinct types of terrains that paint the moon's surface. Stay tuned as we dive into the depths of these lunar secrets. Ever wondered why we always see the same side of the moon? It's because of a phenomenon known as tidal locking. This is a gravitational interaction between the Earth and the moon, where the moon's rotation period matches its orbital period. In simpler terms, the moon takes just as long to rotate on its axis as it does to orbit around the Earth. Hence, the same side of the moon, known as the near side, is always facing us. The other side, often referred to as the dark side, is not visible from Earth, but don't be fooled by its name. The dark side of the moon isn't always in darkness. It experiences day and night just like the near side. It's simply called the dark side because it remains hidden from our view, shrouded in lunar mystery. So next time you gaze at the moon, remember you're always looking at its near side. Did you know that the moon has an atmosphere? Yes, but it's not like ours. You see, while we often describe the moon as airless, it does possess a wispy veil of gases, known as an exosphere. This extremely thin atmosphere is composed of elements such as helium, neon, and hydrogen. But don't go packing your lunar picnic just yet. This atmosphere is so thin that the individual molecules are vastly spaced apart. In fact, they're so spread out that they rarely collide with each other. Instead, they follow ballistic trajectories, much like tiny cannonballs flying through space. This is a stark contrast to the Earth's atmosphere, where molecules are packed closely together, bouncing off each other in a lively dance. The moon's exosphere is a result of the solar wind, micrometeorite impacts, and outgassing, the release of gases from the lunar interior. So the moon isn't completely airless after all. Have you ever noticed the bright patterns on the moon's surface? They're called lunar swirls. These mysterious patterns have intrigued scientists for years, and while we don't have all the answers yet, it's speculated that they could be the result of magnetic anomalies or even the interaction of the solar wind with the lunar surface. Now, if you were to run your hands across the moon's surface, you'd feel something called lunar regolith. It's a layer of loose, fragmented material composed of dust, soil, and rocky debris. Imagine billions of years worth of meteoroid impacts and space weathering processes, all compacted into this fine, powdery substance. And the moon's surface isn't all the same. It's divided into two main types of terrain: the heavily cratered, bright highlands and the darker, smoother morea, which are ancient volcanic plains formed by lava flows billions of years ago. The moon's surface is a testament to its dynamic geological history. The moon is not as quiet and static as it might seem. It experiences quakes and transient phenomena. Similar to earthquakes on Earth, the moon experiences moonquakes. These lunar shakes can be triggered by the tidal forces from Earth or by meteoroid impacts, and were detected by seismometers left on the surface by Apollo astronauts. Now let's talk about transient lunar phenomena, or TLPs. These are temporary changes in brightness observed on the moon's surface. They can last anywhere from a few seconds to several hours. The causes of these TLPs are rather elusive, often attributed to the release of gas or vapor from beneath the lunar surface. These phenomena are a testament to how dynamic our moon actually is and how much there is still to learn about it. So, the moon is full of surprises, isn't it? And who knows what else we might discover in the future as we continue to explore our celestial neighbor.